for those who tak ada berapa nak dengar audio, you can actually watch the video. Okay. I'm not sure, mungkin kena buat poll juga. How many of you actually rewatch the video after group kan, ataupun dalam Facebook. Tak apa. Just record this for the sake of keeping, insyaAllah. So Alhamdulillah, thank you very much to everyone who have managed to answer the questions or the online quiz on chapter 11. Although the deadline is to be midnight kan, tapi I've requested last Thursday kalau boleh siapa yang dapat siapkan awal, kita boleh discuss quiz tu tengah hari ni. Kalau tak, kita akan terpaksa buat benda lain lah kan. Jadi, all in all, Alhamdulillah, thank you very much everyone. Thank you very much to Azam, thank you very much to Arif. Because both of you were the ones yang memang tak tinggal 2 orang je. So I was like, alamak 2 orang macam sayang pula kan. So thank you very much sebab responded to the call, insyaAllah. So you, both of you made session happen, insyaAllah. Alhamdulillah. So without wasting any time, kita akan proceed lah So siapa-siapa yang ada tulis nota your answers, what do you guys buat jawapan hari tu kan, so boleh take them out. So kita akan discuss together lah, insyaAllah. Okay, so everybody ready Yes. Right. For the MCQ part, if you notice, kita extend lebih, tambah banyak sikit soalan kan. Instead of the typical 5 questions, kita bagi 10 question insyaAllah. And then we cut down on the subjective questions. Okay. So, question number 1, we are on chapter current of electricity, previous on electric fields. Next, starting tomorrow, you'll be going through DC circuits. Okay. But we are in the middle lah basically kan. So tiba-tiba soalan dia number 1, what are the characteristics in a solution during electrolysis? Macam flip table lah kan. Apa pula tiba-tiba electrolysis ni, tak ada pun dalam video, tak ada dalam notes and what not, tiba-tiba electrolysis, oh my god. Tiba-tiba kan. Tapi apparently semua dapat jawapan betul. So you guys electrolysis lah kan, because you studied in your previous IGCSE atau Form 4 apa semua tu lah kan. So electrolysis is basically a process when the circuit is not actually connected with a wire. So it's not connected fully when you have a solution. Typically a compound, so usually orang akan guna sodium chloride lah kan. And then bila you turn on the power and turn on the voltage source, and then you see something happen, so adalah charge kan. So this is an example of an electrolysis lah kan. You've got the anode and then you've got the cathodes. So by time you will observe that this type of situation lah kan. Benda tu you boleh dapat dekat dia punya anode and cathode respectively. So you've got sodium ions attracted to the negative, attracted to the sodium attracted to what? Cathode or not? Sodium attracted to the kan, negative lah kan. The chloride ions kalau kan attracted to the anodes, positive negative, negative to positive. And then dia akan emit hydrogen gas lah for some reason. Why? Because solution in water kan. So the charge carriers in a solution during electrolysis. So that means all of the ions located within the solution, what are they? Are they positive only or negative only, ataupun elektron sahaja? So basically answer would be positive and negative ions. So benda itulah yang electricity and actually flow in this circuit kan. So the answer is D lah. Okay. If you have any questions or anything, you can always ask lah. We are actually going through this online quiz, just a matter of kira macam optimizing our session together lah kan. If we actually have separate session for lecture and separate sections for discussing the tutorial or discussing the quiz, then it will not be optimum at our current condition again. So that's why I decided that to have this lecture discussing on the practice questions as well as the tutorial, as well as the online quiz, because apparently you guys want to know kan, how did you fare in your quiz. Lepas tu dapat response tu dah dapat markah lah, you guys kan jenis yang rebellious sikit, mesti akan tanya why they got this wrong and everything kan. So we take point untuk nak adakan this session lah, so that everything can be done here guys. Okay, number 2. So this question, there is a current of 0.24 amperes through a lamp for 40 minutes. How much charge passes through the lamp? So this is quite forward. We've got the current, the value is 0.24 amperes, and we've got the time t equals to 40 minutes. So the question is asking about charge. So we use the banyak kali sekolah kan. So kita guna the formula for charge yang kita dah belajar dalam the kan. Kita substitute I equals to 0.24 equals to 40 minutes, and we have to convert 40 to 60. Kalau siapa yang directly 0.24 times 40, dia akan dapat jawapan lain kan. Dia akan dapat 9.6 columns. Yang mana ada yang jawab B. Kecewa. This is a very careless mistake yang tak sepatutnya happen. So you have to convert first 40 minutes to 60 seconds. So you get 576 columns. Siapa yang jawab B? Aku, cepat sekarang.
Ucap.
Please kan. This T is 40 minutes. It should be converted to seconds. Here you should get 2,400 seconds. Multiplied by 0.24, then get 576 columns. Okay. Alright. Answer is A. Question number 3. When a resistor is connected across a battery of 2.8 volts, there is a current of 0.5 amperes. What is the resistance of the resistor? So this is actually a warm-up question to ingat balik the equation V equals to IR, Ohm's law and whatnot lah. So you got the potential difference as 2.8 volts, you got the current as 0.35. So the resistance is V over I. So this is 8.0 ohms. Although kalau ikut jawapan, dia tengok, dia tulis bagi apa? 8.00 ohm. Sepatutnya kita kena bagi kalau in this example question. Okay? We take this question as an example. How many figures should we put kat sini? 2 kan? Because you got 2.8 volts and you got 0.35. Tiba-tiba jawapannya 3 significant figures. Sudah. Macam mana ni? We have to argue lah kan. Kenapa you buat? You dulu suruh kita buat ikut the lesser significant figure. Now you put 3 significant figures. Come on man. Kan? Nak argue lah kan? Yalah kan? Lepas tu soalan tu pun tanya balik. Sometimes you also put extra significant figure kan, just to be safe lah. So tak perlulah kita nak bergaduh-gaduh pasal tu. Yang penting kita tahu the notation used is using the lesser significant figures. Kita nak apa? Final answer because in terms of accuracy lah kan. Okay. Moving on. Question number 4. A car headlamp. Okay, headlamp. What is a headlamp? This is an example of a headlamp. Nothing to do with transformer. Not. And this picture has got actually nothing to do with the question pun. I just figured it will be very boring. Ada soalan gambar, so saya pun google je lah image. Ni headlamp, nampak macam cantik, cool, okay masukkan tu je lah. A car headlamp when connected to a 12 volts battery converts energy at a rate of 50 watts. How much energy is converted when it is switched on for 5 minutes? So interestingly enough, this question is very interesting, betul tak? Do you agree with me? Why? Because Tak ada jawapan. Betul tak?
Oh,
ya.
I got 15,000.
Yang menariknya, only one person out of you guys yang tanya kat saya. Sir, is this apa?
I assume it was a typo.
Kan? Ada yang memang assume terus typo lah kan. Tapi ada yang double check. Dia macam berhati-hati lah kan. Sir, betul ada typo ni kan. So apparently ada seorang je. Yang menariknya, seorang from this group and the other group pun ada seorang je yang tanya. So dia macam I was wondering, macam ni yang lain-lain yang lain-lain kira macam hantar seorang wakil ke? And you guys macam ada what? Macam tak ada lecturer langsung kan. So dia macam you share answers ke macam mana, kita macam okay, kita hantar Iman lah. Iman, tuan Iman.
Yes. No. Arif Iman is our representative.
Betul lah kan, saja je lah. Okay. Yelah kan sebab ada yang baru siap pagi ni kan.
Hey, janganlah sir.
I wasn't saying anyone.
Arif is very peka sir. He asked me.
Oh ya. Nanti screenshot kita hantar kat Mahkamah. And okay, this question is quite interesting sebab dia bagi information although we do not use all of the information, betul tak? Just to catch us off guard lah. So bagi potential difference 12 volts but we actually don't use this value. Kita diberi rate of energy conversion which is in watts. Is actually equivalent to power kan? Rate of change in energy similar to current, the rate of change in charge. If you recall the definition of a potential difference, although the second definition of a potential difference, kalau you refer balik you punya notes, V equals P over I ataupun dalam bahasa kita P equals to VI lah kan, atau P equals to I kan. Tapi the formal definition of a potential difference is V equals to P over I. That means power per unit charge lah kan, the power current. Cumanya we can actually find ataupun the power and the current as well, maknanya nak definekan potential difference tu in terms of rate. Kalau you rujuk dekat you punya notes yang dia punya mind map tu lah, nanti you akan tengok. Last slide nanti saya akan bagi tahu pasal this concept. Okay, so the power is 50 watts, so the time is 5 minutes. So energy we know is equal to P times T because power is the rate of change of energy. That's the definition of power. So we want to know what is the energy converted. So in the values 50 times 5 times 60, you get the value of E equals to 50,000 joules. Yang mana tak ada jawapan, but typo lah. Dia ada terlebih. Macam mana? This set of question macam sikit kan. Yang previous question tadi tu significant figures. Yang ni dia terlebih kosong. Mungkin sebab PKP kan. Semua pun macam dah. Allah Alam kan. Okay. Apa kita mesti menang. Alright. Moving on, question number 5. The current of 2 amperes passes through a component of resistance, 24 ohms. What is the rate of energy transfer? So here, given I, 2.0 ampere, 24 ohms. So, kat sini kita boleh tahu dia punya voltage kan, cumanya dia voltage, so dia punya rate of energy transfer. So although this is a MCQ question, so kita tahu yang nak cari dalam which is the definition of power and rate of energy. So janganlah tiba-tiba fikir nak cari energy ke, tak boleh nak cari energy. In this case kita tahu berapa dia punya time kan. So kita tahu dia lah power because the definition of power is change in rate in energy. So the energy rate transfer equals to power P equals to VI. So here you have a choice to just memorize all of the equations. V squared apa over V squared over R V squared over R ataupun V squared over I ke, ataupun ni in this case I squared over times R, semua macam-macam formula yang you boleh hafal kan. Tapi you don't have to kan. Have to memorize two main equations. One is V equals to IR, the other one is P equals to VI, and then you play around with this based on the information that have been given to you. The answer for B is P equals to R. And then you substitute the values. Make sure you substitute it correctly. no issue on the conversion of the units, milliamperes ke apa, all the units are in SI units already, but it is a matter of whether tekan kalkulator tu betul-betul ataupun tidak. So 2 square equal 4 times 24, you get that is 96. Okay. Boleh ke semua? Am I going too fast or the pace is okay? Nak slow sikit ke ataupun alright?
Okay.
Okay,
Mengantuk hari, mengantuk you can actually rewatch the video after this. I ingat. Alright, moving on. Question 6, what is the unit of sensitivity? So this is interesting. Sekejap. Let me change this one. Sorry. This is question number 6. Share my screen. Nampak? So this is actually behind the scenes lah. Bila you guys submit your question, so this is what is happening behind the scenes. 19 responses and this is the average mark. I believe most of you did this question well sebab median point plus 9, average is 8.95 out of 10 and this one is the entire question. Kalau dalam Google Form ni dia hanya assess for the objective atau MCQ sahaja, MCQ questions. So kita boleh set terus jawapan, although untuk subjective question pun boleh juga, tapi yalah kadang-kadang darab 10 negatif 7 dia tidak as darab tu kena star kena X, so dia macam very complicated. So we just set the untuk auto mark ni ialah untuk apa nama benda ni, MCQ question. So overall out of 10 MCQ questions, the range of points is 7 to 10, so it's quite good lah. So you can give yourself a round of applause because you did well, you did good, insyaAllah, alhamdulillah. So let me just show you. Oh, this is quite dangerous. Silap pula. Okay, let me just play around with this one. We are at question number 6 kan?
Yes.
Okay, sekejap. Saya buat cepat-cepat. Oh, laju tak nampak kan? Okay. Kalau dia question number 6 ni, the answer is B. Tapi ada yang jawab A, ada yang jawab C. Walaupun sikit tapi menarik juga kan. Kenapa dia jawab C So let's answer. Kalau kita tengok the unit of resistivity. Okay. So, kalau siapa yang jawab A, mungkin careless lah. Mungkin dia ingatkan resistance. Kalau resistance it is in ohm, betul. Tapi kalau resistivity is a different unit altogether, betul tak? Kalau ni dia lain lah. Dia jadi lain lah. Mungkin kalau siapa yang jawab D tu memang tak tahulah kenapa dia jawab D kan. Kalau ohm per meter tu mungkin dia tersilap tengok ke apa kan. But the unit of resistance is ohm, which is A. But the unit of resistivity is the symbol is rho, is given as rho m. Why is that so? Because it is given as this is the notes. This is the actual notes kan. So anyone show us to everyone. I'll let you annotate how the dimensions are actually derived in order to come to the final resistivity unit is ohm meter and not ohms per meter. So mungkin yang ni ada orang confused as ohm per meter. No, it is not. It is only ohm meter. Okay. Can anyone show us here how to derive the formula ataupun the units of rho using this? Anyone? You guys prefer untuk saya pilih orang terjawab ke ataupun you volunteer?
I think Acap wants to volunteer. Yeah.
Alif, silakan. You requested for annotation, so you are the one who volunteer now. Are you?
Yeah. And, yeah.
Can you show us how did you
How did I?
How do we come to the final unit of resistivity for S ohm meter?
Okay. First, I list down the for R, the unit is ohm, right?
Okay. So you are annotating using your phone, is it?
Yes. And for area, it's meter squared, right?
Are you annotating it anywhere? I can only see row.
Okay, jangan.
Yeah.
Someone made an error to my annotate. I'll write it down.
You write it down and then?
Okay, wait. So for resistance, it's ohm. For area, it's
Okay.
Meter square.
it's meter squared. And for length, it's meter. Yeah, right. If we punch everything into the equation, we get the unit for rho is ohm meter squared per meter.
Right.
So when we simplify this, we get
Cancel that.
Yeah, we cancel it out, and we get ohm meter. Okay.
Okay, thank you very much. Round of applause to Alif. Thank you very much for the active participation. I'll try to make sure you get extra marks. Sure.
Thank you.
Okay, so that's how you derive the units for resistivity. Resistivity itu is a measure of how the metal is resistant lah kan. Okay, moving on. Question number 7. Okay, this is interesting. Which of the graphs shows the IV characteristics of an OP conductor? So actually go into answering the questions, which I everybody got it right. Tengok lah kan. Question 7. Tengok tu 19/19 correct responses 100%. Mantap. Okay. So instead of just knowing the answer is D, because we know it's an ohmic conductor, let's just discuss a few of the characteristics that are within the. Can anyone annotate to us? Okay, again annotation. Can anyone annotate to us the characteristics of the explain and describe and come to the conclusion that this graph is actually representing what type of conductor? It's a volunteer basis. Would you like to volunteer or would you like for me to point something?
I rasa. Okay. I think, sir.
Yes, Arif.
I think, okay, I don't think I need to annotate it, but then just my opinion that the semiconductor diode.
Number one, thank you very much, Arif. Number one, I thank you very much, Arif. Number two, I think you are flipping your notes, isn't it? No.
No.
Rasa ada bunyi ke?
It could either be a semiconductor or like a thermistor. Semiconductor lah, obviously.
Okay, thank you very much. Okay, thank you very much. That's a good thing. But I would like to ask everyone to do before concluding that, okay, this is representing what? Can you describe first the graph? Instead of concluding, okay, A is semiconductor, B is filament, C is thermistor, D is metal conductor. No, before we come to a conclusion, can we go into the characteristics of each graph? Like for example, graph ini dia apa karakteristik graph ni? Gitu. Seorang. Anyone?
Never mind.
Again. Arif, do you want to try again?
No, sir. I done my part.
Congratulations. Okay.
Thank you.
It's negative. Current is negative. Okay. Thank you very much for the question, Selma. I believe this is a question that you would like to ask before actually attempt to explain else the characteristic of this graph. Okay? Yeah, because dalam rules dia ada negative sign kan. Okay, so basically the negative is just representing the direction. Okay, if you flip it, it's actually the same. So it's a matter of going from right to left or left to right. Itu saja. Although it is sebenarnya beza lah kan kalau option number B tu kan. Alright, so does me answering your question help you in a way of you being the person to explain to everyone else the character of option A?
I want to try.
Yeah, sure. You can request annotation and I'll gladly approve. Anyone? So is it that the circuit is flipped? It's not that the circuit is flipped. It's a matter of the directions. It's alternating. So if you have an alternating current, so the graph will be flowing from top to bottom and bottom to top. Okay, so apparently we've got of course current has direction. Somebody just rearranged my drawing for some reason, I don't know why. Sebab dia ada 3 je culprit kat sini. Dia sama ada Adlina who's trying to answer, ataupun Alif, ataupun Emily. So which of you yang sebenarnya yang pandai-pandai pergi remove kita punya drawing pula?
Saya
Arif.
tertekan kira. Saya
Jangan tertekan jangan tertekan. Okay, we got A. What's this? Change in I. Dia macam main win, lose or draw kan? Kita macam anticipating. Tulis apa ni sebenarnya? We increase. Resistance decrease. Okay, that's in terms ada argument kan? Okay. Okay, can you explain?
Okay. When we look at the gradient, as the gradient increases, the gradient
Where is the gradient? Can you show it to us?
Here.
Okay.
The gradient increases. The gradient represents 1/r, so r decreases.
So the concept that you are that we take here is the gradient of a IV. Of a IV curve is equals to 1/r, where r is actually represent the resistance, betul?
Yes.
Okay.
Okay. And the line is not straight. It's like exponent, right? So the change in R increases as voltage increases.
So that's why you have the resistance increases, because the gradient is increasing, isn't it? The gradient of EI over V curve is increasing, as you can see here. So the resistance is actually decreasing. So for these characteristics, when we have an increase in change of current, but we have a decrease in resistance, probably for some external factor, probably temperature. So what can we conclude for this graph A? What is it representing?
thermistor.
It is a thermistor. Thank you very much. Congratulations. Okay, it is a thermistor. So the opposite operation of a thermistor is actually referring to the graph C. Kalau A ni ialah thermistor, if A is thermistor, C is the opposite, which is actually referring to a filament lamp. Apa? Kalau kita tengok dekat graph A ni, kalau dalam graph A, dia punya gradient meningkat. So it is indicating a decrease in resistance. But for this graph, what happens to the gradient? The gradient is decreasing. So kalau gradient decreasing, maknanya it is indicating that R is
Increasing.
increasing, isn't it? Okay, for some reason. So probably there is an external factor, for example, temperature. So for both situations, A and C, temperature is increased. When the temperature is increased, the effect of resistance ataupun dia punya tindak balas, tindak balas resistance terhadap temperature for material A and material C are opposite to each other. For example, if you look at C, which is the thermistor, when you increase the temperature, the resistance increases. So kalau you increase the temperature, the resistance. But for a thermistor, when you increase the temperature, the resistance decreases kat situ. So this is what we call, kita panggil NTC kan. NTC, walaupun thermistor ni dia sebenarnya dia ada dua jenis. Dia ada NTC dan dia ada PTC kan. Apa entah TC ni apa. Teluk. Betak aku apa. NTC is negative, apa entah carrier something like that. I can't really remember what's the one is negative and the other one is positive. Kalau positif PTC itu PTC atau PNC betul lah PTC lah kan. Refer to the note kan. Kalau PTC itu memang acting similar to a element. Thank you. Thermal. T is the thermal coefficient. Okay. So kalau NTC itu negative thermal coefficient. Kalau PTC is a positive thermal coefficient. So kalau kita ada positive thermal coefficient, maknanya apa? Increase thermal, increase resistance. Tapi dalam skop pembelajaran kita, we only about NTC. Maknanya apa? With increased temperature, resistance increase. So dia opposite kat situ. The graph is like this lah. For A and C, when you increase the temperature, what happens is the change in current will increase drastically compared to potential difference, and you will get a decrease in resistance. What about B? I think Iman mentioned dalam chat tu, dia kata B is of diode kan, semiconductor diode. Betul tak semiconductor diode? Okay, before we go further, can anyone draw me the symbol of a semiconductor diode? Symbol in a circuit. Anything? Would like to annotate? Thank you very much, Adlina, because you did a good job in explaining the relationship between I, V and R. Okay, who is ni dia macam multiple orang. Oh, ada 2, 3 semua nak berbuat pahala. Masya-Allah.
Sure. My one is the orange one.
Yours is the orange one. Oh, I see. Why are they disconnected?
It is annotation, very hard to do.
Okay, what about the pink one? Sorry, purple one. Purple.
Oh my god.
Alicia. Okay, alright. Okay, keep on drawing. Can you draw me the because we know semiconductor, thank you very much. Again, this is the symbol of the semiconductor. Although Arif punya tu macam dia buat sketch kan, macam cantik-cantik. Dalam normal circuit jangan main-main sketch kan. This is not art class
And also,
Limitation. Tapi nak ceritanya, okay, there are two types of biases in semiconductor diodes, betul tak? Dia ada forward bias, dia ada reverse bias, betul tak? What are the differences ataupun what is the difference between forward and reverse bias diodes? Can anyone show? Okay, show me on Kalisha's drawing. Show me a positive, a forward bias diode. On Kalisha's drawing. So what would you do to indicate that it is a forward bias diode? Okay, the signs, isn't it? The positive and negative signs. Thank you very much. What about, okay, on RF drawing, so apparently it is useful, alhamdulillah. What are the signs for a reverse bias diode? The negative, positive, shaky. All right. Inshallah, you'll get used to it. All right. Thank you very much. So we've got here. This is a forward bias, The forward bias diode, and this is the reverse bias diode. So we are discussing graph B. For graph B, the area in which we have this relation, so this is the forward bias, okay? Whereas the tail ataupun on the negative side, this is the reverse bias, okay? This is reverse bias kat sini. Okay, dia dah macam serabut lah kan? Kita pilihkan semua lah. Okay. So kalau dalam semiconductor, as you all know kan, kalau the diode is connected forward bias, that means it will allow current to pass through. But if it is on reverse bias, maknanya dia punya direction tu different. So sebab tu lah, dia takkan bagi current lalu. Just a small current would do. Okay. So dia punya kesimpulan lah, Option A is a thermistor. It senses temperature, and you've got this relation that has been described by Adlina just now. And then you've got option B. This is the semiconductor diodes. We've got two types of semiconductor diodes: forward bias and reverse bias. Forward bias conduct with rapid increase I as B increases. As reverse bias, very high R, thus I is approximately equals to 0 lah. Walaupun dia taklah entirely 0, dia akan ada juga conductivity, adalah electrons yang berjaya untuk nak pergi juga. And as for C, it is the filament lamp. So if you can observe, compare between filament lamp and thermistor. Although filament lamp is not actually intended to sense temperature, for some, ialah sebab dia generatekan light dan dia generatekan heat. Tapi nak ceritanya, dia ada this opposite punya characteristics kan, especially for R and difference in I. R here is greater when you increase i.e. you increase temperature. We already discussed. And then for D, it's one metallic conductor, ohmic conductor. Why we consider D as an ohmic conductor? Because current is directly proportional to the potential difference. We've got constant R.
okay.
Alhamdulillah. Any questions? Tak ada lah Okay. So the answer is D. Okay, rehat sekejap. We take a break for 1 minute. Bukan take 5 minutes. Sebab kita ambil air pun tak boleh sebab tengah berpuasa kan. Rehat sekejap, okay? If you have any questions, you can ask me.
So I have a question. Biasa hilang dah.
Ya ke? Kan?
Bila PKP nak habis?
Dia ada satu hadis. So kita ambil hadis lah. But I don't know. That is a good question. Tapi if you don't realize, sekarang kita dah masuk PKPB. PKPB PKP bersyarat.
Yeah.
So semua orang dah keluar kan. I'm not sure. What about your parents? Are your parents working now?
They're working from home.
Kerja ke? Vaksin sebab dia taklah PKP dengan vaksin kan. Vaksin probably is like next year kan. I see ada yang kena pergi office jugalah kan. Betul lah. Dia punya risk yang ada. Okay, let's proceed. Question 8. The diagram shows two wires. They both made from the alloy Eureka. Wire 1 has length L, diameter D, and resistance R. Wire 2 has length 2L and diameter D. What is the resistance of wire 2? Okay, let's see question 8. How do you guys fare for question 8? Ada casualties banyak juga So only 63% of you managed to get it correct. That is interesting. Okay, I would like to invite anyone to try to answer this question. Show the working on the board, on the screen. Silakan, anyone who wants to annotate. Any takers? Doesn't really matter if you cuba atau nak. Okay, thank you very much. Ada dua. Who is the red one and who is the purple one? Siapa ingat? If you like to. Tak nak bagi tahu lagi. Okay, you keep it a mystery. So at the end only we will know probably. Ataupun dia akan just keep quiet. Kalau betul dia mengaku, kalau tak betul dia tak nak mengaku nanti. So can you explain while drawing? Hello person who is annotating.
I think Azam is annotating lah.
Azam. Okay, R equals to Li. That's really
That's not me.
okay. That's so LA. I don't know what is the name. Oh, okay. So it's been erased for some reason. We still don't know who is it. I can actually know, tapi kan nanti. Oh, tiba-tiba dia tukar kata. Is it the same person or different?
Maybe it's the same person.
Menarik juga. So R2 is equals to okay, hello mystery person, you actually went through the board. You still don't know who. Habis padam terus. Oh, yeah, okay. It's good for you to keep your phone smaller so that it could fit in the board. It's 2L, okay. Over 4A. So can you explain why is it 4A? For some reason. Wow, you are really keeping it in the stuff. You spiral squared, okay. R equals to D over 2, right? So when you substitute R equals to D over 2 into the pi R squared, you'll get what?
Is this Ikmal?
Maybe.
Still. So R equals to D for some reason. Not sure. I don't know. Can anyone recognize the handwriting? Of course lah kan. Handwriting tulis dengan tulis laptop lain kan. Okay, mystery person, are you done? Boy, you are really keeping quiet. So, a few options lah kot. Siapa yang sedang menjawab sebenarnya? It's either Arif, probably. No,
No, it's not Arif.
mungkin Alisha, mungkin Iman.
No, it's not me.
Iman.
Not all.
So siapa?
Iman.
Iman. Is this you?
Yes.
Come on.
You guys cannot hear.
So,
Okay.
okay, thank you very much. Berlaku. Okay, so basically that's how you do it lah kan. You substitute into the equations. First, you have the relation between R and pi L over A. Okay, pi L over A pula. R equals to rho L over A. And then, equation ni ada salah sikit lah sebab dia tak gunakan the pi is missing. Okay, if you want to convert between directly proportional to the equal sign, there must be a pi somewhere here. Okay, so pi, A, which will include pi dekat sini lah. Sebab the cross-sectional area of this wire is assumed to be a circle. So when this is a circle, it has to be pi r squared. However, we are only given the diameter. So R is equal to D over 2. Okay? So for the first wire, we have this relation. R1 is equal to rho 4L1 divided by D1 squared. Missing a pi there. Okay? There must be a pi there. Okay? Tapi tak apa, nanti bila I send the slide over to you, saya akan betulkan. But for R2, we use the same relation and we substitute. L2 is equal to 2L1, D2 is equal to 2D1. And this is squared, so dia akan jadi cancel out, ke atas bawah, dia akan jadi 1 over 2. So 1 over 2 of R1. Okay? So the answer is B. Are you guys clear with this?
Yeah.
Okay. So I skip dia punya daripada this step to this step. So you have just to be careful lah kan. 4, 2, 2 squared. So 2 squared ni cancel out the 2. Dia akan jadi 4. Dia ada something happen kat sini kan. Betul tak betul, masih tak betul je ni. Betul ke tak ni sebenarnya?
Should we know?
Betul lah kan. 4 ni kita kekalkan and then it's between these 2 squared lah kan.
Yes.
So dia akan 4, 2/4 dia 1/2. 4 ni dia kena ada kat dalam ni lah kan, because 4 ni dia sama dengan R1 here. So dia akan jadi half R1. Okay? So that's it. Thank you very much, mystery person. Alright, question number 9. So I won't let anyone annotate unless they declare themselves who are they. So the graph shows the variation of the resistance of a thermistor with temperature. But the question is asking which conclusion can be made directly from the graph. So bila mana dia cakap directly from the graph, you don't have to know what type of material it is, apa semua. So you just have to know interpretation of the graph. So kat sini kalau kita tengok with a glance, we've got resistance and temperature. So there's no voltage, there's no other potential difference, there's no current or whatnot. There's only the two variables that are constant here are resistance and temperature. And we know by increase in temperature, a decrease in resistance. When we decrease the temperature, the resistance go up. So kalau kita tengok one by one, the answer A, the resistance of thermistor increases. The current, nampak current? No, this nothing to do with current, nothing to do with the potential difference. So it's either between C and D. So kalau C dia kata resistance increases when the temperature decreases. Betul lah kan? Kalau D resistance increases when the temperature increases? No, it is not directly proportional, kan? It is not proportional juga lah, either directly or not. So the answer is C. Okay. Question number 10. This is an interesting question. A student has a metallic conductor and a semiconductor. The temperature of the two materials is raised. Which line in the table correctly shows the change in their resistance? Who would like to attempt to answer and explain the question, the answer for this one? Let's just see jawapan hasil survey. Most of you got it right. 78.9%. Masya Allah. Only 4 salah. So out of the 80% of you, can anyone explain why the answer is C? If you like to annotate, you are welcome to do so. If not, then just explain verbally.
Can I explain, sir?
Yeah, you can. Silakan.
Okay. For semiconductor, in this case we assume it is a NTC semiconductor, which means negative thermal coefficient. So when temperature increases, the semiconductor will decrease. But metallic conductor, as we usually know, it is a positive thermal coefficient conductor. So when temperature increase, the resistance also increase.
So your assumption is based on the NTC semiconductor, is it?
Yes.
Negative thermal coefficient semiconductor. Not
Yes.
semiconductor. Interesting. Thank you very much, Iman. Can we have the second opinion here? Anyone else? Why is the semiconductor increased when the temperature is raised? The resistance of the semiconductor decreases when the temperature is raised.
So can I try?
Yes, you may. Silakan.
For metallic conductors, this is based on what I read. For metallic conductors, when temperature increases, the particles or the atoms of the metal vibrate more. So there are more collisions between the atoms, resulting in larger resistance. But for semiconductor, so we learn about semiconductor, like their electrons are bounded to the atoms. So when temperature increases, the free electron gets more energy to escape from the atoms. That is just what I read.
Okay, thank you very much for your attempt on answering the question. So both are considered okay, Alhamdulillah. So kalau kita nak ingat balik dia punya semiconductor lah so semiconductor there is actually a region kat sini kan. What is the name of the region between the negative sign? What is the name of the region?
Wait.
Sorry?
Depletion layer, sir.
Depletion layer nama dia. Depletion layer. So kalau increase in temperature, so this layer would deplete, bukan deplete, dia akan jadi semakin menipis. So it would enable the electrons to, macam yang Kak Syah cakap tadi tu, to freely move, lebih senang. Maknanya dia punya resistance tu akan berkurang. So less energy is required to free themselves from the bonds that are sedang mengikat mereka. In English, what is that? That are tying them up together, is it? Tu cerita semiconductor lah Because semiconductor dia bukannya macam normal transfer of electrons and holes, tapi dia akan ada that depletion region. Sebab itulah dia ada certain condition forward bias saja yang dia boleh bergerakkan electrons tu. Okay? So hopefully benda tu you can read again in order to fully understand it more clearly, inshallah. Alright? Okay, moving on, subjective questions. Boleh ke? Any questions so far? Okay. Question 11. The graph shows the IV characteristics of a filament lamp. Does the lamp obey Ohm's law? Explain your answer. Yes or no? Yes or no?
No.
Answer. Yes or no? Yes or no?
No.
No.
I nak main poll.
Oh,
Yes or no?
because because apa, the voltage is not directly proportional to the current.
Dah saya voltage not directly proportional to current ataupun current is not directly proportional to the voltage lah
Yeah.
Okay, so it's not obey Ohm's law. Do not have to comment on the resistance constant throughout. It's not constant throughout because that is another question that is for you. Question part C kan. Okay. Part B, calculate the resistance of the lamp at 4.0 volts. So of course, to calculate the resistance, you need to eyeball the values at 4 volts. The value of the current is 60 milliamperes. So from the graph, I equals to 60 milliamperes. Make sure you convert 60 milliamperes so you get 67 ohms. Why 67 and not 67, 66.7? Because the figures 4.0 volts. Good job. Alright, question number C, describe how the resistance of the lamp depends on the current. So how do you comment on this? The resistance is, like we discussed just now, the inverse of the gradient. So here the gradient is decreasing. So since resistance is the inverse of the gradient and gradient is decreasing, the resistance must be increasing. Okay? Yeah. Play around with the concept of the resistance is the gradient of the IV graph, which is the inverse of the gradient of the IV curve. Alright? Question number 12. A negative temperature coefficient, thermal temperature, thermistor and its connecting leads are coated with a high sensitivity plastic material. The thermistor is placed in a beaker containing hot water. The temperature of the water is kept constant at 80 degrees Celsius. The I characteristic of the thermistor is shown below. So for some reason, it's a straight line lah. So calculate the resistance of the thermistor. We've got the IV curve. IV line lah so the resistance is the inverse of the gradient, which is equal to V over I. So the answer is 150 ohms. No problem on that unless you wrongly convert milliamperes. Always remember that. I'm not sure. I've been repeating all the milli conversion all the time for every discussion that we had, but I believe there will be this mistake repeated over and over again. So I sincerely hope that you do not repeat your past mistakes in order for you to be able to pass through whatever the challenges that are in store for you in the future, inshallah. Okay? Okay, question number B, it is asking sebenarnya ialah apa ni? Okay, the animation going all around. State and explain the change, if any, to the shape of the graph of I against V, where the temperature is lowered and maintained at 30 degrees. So we know this is an NTC thermistor. Increase in temperature will result in decrease resistance. So it is inversely proportional. But in this case, the temperature is decrease sebab dia water kan. Kalau nak increase boleh juga kan. Kalau kita decrease saja kan, biar tak payah buat apa-apa. So decrease in temperature will result in an increase in resistance. Therefore, what happens to the graph? The graph will have a smaller gradient ataupun it will become less steep. So I invite any one of you, hold on. So I invite any one of you to annotate and draw here the shape of the graph at 30 degrees Celsius temperature. Silakan. Okay, Farah Adriana Sofia.
Yeah, smaller gradient.
Yeah, so how do you draw it on the Simple.
Oh my god. Oh, this is so hard.
Yes, yeah, it's not good. Okay, so I believe you wanted to draw it somewhere like
Yeah.
thank you very much.
Sorry.
It's okay. Just for you guys to actually feel the hardship of everyone else. The lecturers are trying to teach you using this this on-screen punya tu kan. Unless you have an iPad lah, senang sikit kan nak draw kan dekat dia tu. Okay. Alright, so that is the answer. Again, smaller gradient. But dalam soalan ni, you don't have to draw because the question is only asking you to state and explain. Okay. But in case there is another question that is asking you to draw, then you can actually draw any region where it is showing a lesser steeper gradient, inshallah. Alright. Okay, question number 13. So this is question number 13. What is made of a material of resistivity rho? Write an equation for the resistance R of a wire of length L and diameter D, similar to what we did just now. Cuma dia suruh derive kan. So given the formula for the resistance of a formula, R equals to rho L over A. So assuming that the wire is made, the cross-sectional area of a wire is pi r squared. So you substitute R equals to D over 2, similar to the previous question. So R is equals to 4 rho L over pi D squared. Okay. Straightforward kan? Jangan gelabah tak ada nombor Ni semua ialah huruf dan simbol saja. Okay. You do sometimes get this kind of questions, inshallah. Okay, number 14. Says here, Mangenian. Teringat ice cream Magnum dah sekarang. Okay, steadfast insyaAllah, istiqamah. You've got 3 hours for iftar. A manganese wire of radius 0.15 millimeters has a resistance of 5.33 ohms per meter of length. Calculate the resistivity of manganese. So we use the formula yang kita guna tadi lah kan. To calculate the resistivity using the formula R equals to rho L over A. Kita rearrange the equation. Kita dapat rho equals to AR over L. And then substitute A, assuming it is a cylindrical wire of 4 pi R squared. Pi R squared R over L. And then substitute the values. Kenapa kat sini L ialah 1 meter?
Per meter length.
Yes, because dekat sini dia kata per meter length, 5.33 ohms per meter of length. So we assume it is a unit resistance, 5.33 ohms per meter, which is per 1 meter. So kita masukkan L equals to 1 meter, in case anybody is wondering lah. And then carefully convert 0.15 millimeters to meter. So you get the value 0.77 times 10 to the power minus 7 ohms meter. Don't forget the units, but you will round it off to the nearest 2 significant figures because 0.15 millimeter. So you get 3.8 times 10 to the power minus 7 ohms meter. Correct value, correct unit, you get the entire mark, insyaAllah. Okay. Part B, okay, somehow. Pelik lah. Explain how your answer A would change if the manganese wire had twice the radius. Will there be any change? No, there won't be any change. Why? Because they are of the same material. So if you use the same material, resistivity does not have any effect. Dia takkan ter-effect dengan different dimension because resistivity is a characteristic of the material itself. As you remember, kalau tengok balik dalam contoh yang kita buat tadi tu, where is it? Yeah, this one. The objective question kan. Question number 8 kat sini kan. If you notice here, kita assume the rows are similar. Dia sama kan, rows dia lah sama. Sebab apa? Because both of the wires from the alloy Eureka. That means they are not using the different material. They are of the same material. So same material will have the same resistivity. So that is why if we had the same wire, dia punya radius lebih tebal, twice the radius, there will be no change at all in the value of resistivity. Since it is on the type of material, structure, and not its function. So this is an example of a list of different materials with different values of resistivity. The unit is still ohms meter. So kalau tengok, kalau kita ada silver, resistivity tu is very low, so high conductance lah kan. Tapi kalau kita ada hard rubber ni dia susah sikit lah kan. Baik, susah apa? Susah untuk nak conduct electricity. So it's a good inhibitor lah kan, compared to a conductor. So sebab dia ada high resistance kat sini. Alright. So that's it for our questions. Macam mana semua? Dapat berjaya menanda kertas sendiri dengan baik?
Yeah.
Any disputes? Because no paper. Yes. Any questions regarding this chapter? Hadith has raised a hand. Yes, Hadith. Any question? Hadith.
Presiden tunggu breast.
Press. Kalau dah masuk kan. Nak buka puasa.
Sir,
Yes, Karisha.
I want to ask for number 12A. Number 12. So I understand that resistance decreases, but doesn't the gradient represent 1 over R? So doesn't it become steeper?
You mentioned that the resistance decreases, eh? Okay, here let's look at the question again, okay? Dia kata, state and explain the change, if any, to the, you are referring to 12B kan? Bukan 12E.
Yes.
Right. Okay, state and explain the change, if any, to the shape of the graph. What happens when the temperature is lowered, eh? So when the temperature is lowered, what happened to the resistance? Will it decrease or increase?
Oh, resistance increase. Oh,
Dia
okay.
guna NTC, dia terbalik.
Oh, okay.
Dia bukan filament ataupun dia bukan APTC. Dia guna NTC, okay?
Okay. Thank you.
Tak ada dispute lagi. Because kalau kita nak resistance increase, so dia punya gradient kena increase kan. Tapi because here temperature decrease, resistor increase. So gradient kena kurang lah in order to achieve a higher resistance. Okay ke?
Okay.
Alright. Any other questions? Nak pilih slide mana satu ni? Ada? I guess not. So everybody alright?
Yeah, we're alright.
Alhamdulillah. So to end our class, we'll go for the bonus slide.
Woo!
InsyaAllah. Okay. So bonus slide ni dia tak adalah random sangat. Dia macam revision juga untuk chapter ni. Okay, insyaAllah. Base results. Potential difference. Okay. We've got two formal definitions like I mentioned earlier on. The first definition goes by the formula V equals to W over Q, which is the energy transferred atau work done per unit charge. Ataupun kalau kat situ dia tulis lah, the potential difference between 2 points in a circuit measures the electrical energy transferred by each column of charge. Maknanya of course kalau kita ada a full circuit kan, kita boleh tahu dia punya potential difference of the source. Kita boleh tahu the potential difference between a resistor ataupun any electronic component that is connected to it, either in series or in series and parallel. Okay, SI unit is in volts and the formula is V over Q. But the second definition juga power dissipated per unit current, as I mentioned before. V is equals to P over I. Walaupun kat sini itu teacher Hanizah punya note, dia kata also be considered here, where V is formally equals to W over T over Q over T. Why? Because T equals to W over T and I equals to Q over T. So if we go deeper into it, kita akan tahu lah sebenarnya this is actually a potential energy that is generated from a source in order to power up the entire circuit. So if you have an electrical appliance connected to it with enough energy and potential, it can be achieved. Maknanya apa? It can be powered up. So what am I actually trying to say? What am I trying to share with you in this bonus slide this time? Of course, it has something to do with potential difference. So now, let's one hadith of Sallallahu talking about potential difference. With potential difference, you can actually, like I mentioned just now, current will be able to flow. That means you can actually move the electrons. When you move the electrons, current will automatically flow in a different direction. When there's a flow in electrons along the then you will have current flow into it. When passes through a resistor or any electrical component that contains an internal resistance, you will have that potential difference across it. Kan dia akan ada work done lah kan, from the battery ataupun from the source, either AC ataupun DC. All of the other electronic components will be able to function properly if you have that potential difference connected correctly. Betul tak? Kalau you ada DC circuit, positif negatif, you terbalik. Kalau you letak terbalik, current will be able to flow ke tak?
No.
No, it will not be able to flow unless you have a diode yang apa asalnya reverse bias tiba-tiba jadi forward bias contohnya lah kan. So dia according to the circumstances, have that potential difference arranged in a situation ataupun arranged in the correct direction, then it will achieve its purpose of being able to supply voltage throughout the circuit, hence enabling the circuit to function as it has already been by the electrical engineer, the electronics engineer. So what has it got to do with the point that I'm trying to raise this evening? We as human being has got potential. Betul tak? You cannot deny that you have this potential. The fact that you guys are already here, you guys are here at Kolej Seremban. The cream of the crop yang paling power sekali tau. SPM daripada 500,000 tu, only roughly 50 to 60 people have been selected by Mara to go to overseas. So dia bukan kaleng-kaleng lah orang kata kan. Nak ceritanya you guys are the top of your batch. Walaupun MRSM saja, tak compare dengan BDP. Tapi nak cerita nak masuk MRSM pun payah juga lah kan. Mungkin ada yang saya SB masuk MRSM juga kan. Cik. From somebody who is also antara kan. Nak ceritanya, you guys are selected by the Ministry of Education somehow. Bukan Ministry of Education kan, dia Kementerian Buah Bandar kan, marah kan. And you will have the opportunity, scholarship to further studies. That's because of why? Because you are the chosen ones lah. Nak cerita you are the chosen ones kan. So bila mana you are the chosen ones kat sini, it shows, it actually proves that each and every one of us, human beings in general, actually you guys have got potential. Tremendous potential. You have got potential, EQ potential, SQ potential, apa jenis quotient lah kan. Semua ada potential kan. And very complicated mathematics, very complicated concept, physics and chemistry. Power lah kan. This is actually consistent by the hadith of the Nabi Sallallahu Alaihi Wasallam. Rasul Sallallahu Alaihi Wasallam, he narrated by Abu Hurairah, dia nak kata dalam riwayat Muslim, it says An-Nabi Sallallahu Alaihi Wasallam qala an-nasu ma'adid khairuhum fil jahiliyah khairuhum fil Islam idza faqahu. The translation is from Nabi Sallallahu Alaihi Wasallam said, mankind are metals. Metal bukannya filament ke metal conductor, bukannya NTC ke PTC ke, metal this is what Nabi SAW described metal, and we've got a specific metal that is described in the Quran, which is Surah Al-Hadid. Hadid is steel, alloy, that's it. Tapi nak cerita, we focus on this hadith. Dia kata mankind are like metals, best of them is best of them in Islam, which is referring to submission, when they understand. Dan nak ceritanya, all of the human beings have potential, and we are already proven that you guys are kira macam power gila lah banding dengan SPM batch tahun 2019 kan? SPM last year kan? A few months ago kan? Tak ceritanya, once you guys are kira macam the best of the metals out there. If you can recall, kalau ada list yang tadi, yang the previous slide kan ada list of metals and their resistivity kan. So the lesser the resistivity, the more they can conduct electricity kat situ kan. The more they have the potential difference. So the higher the potential. So these human beings, and Nabi SAW said, they have that potential and they can either channel their potential within two avenues. One is in ignorance, which is jahiliyah, and the other one is in Islam, which is in submission. And this is where the junction in which we have to decide whether we want to channel our potential that we have at the moment. You guys have lah kan, tapi overseas semua kan. So semua kehebatan, boleh nak power semua result IGCSE, orang ambil SPM je kan, tapi you guys form 4 pun nak ambil exam juga kan, Masya Allah kan. Orang kira form 4 tu kira dah macam honeymoonnya kan, tapi you guys ambil juga level kan, Masya Allah kan. Bukan saya nak sebenarnya parents saya yang suruh. Tapi nak cerita, you are able to withstand all of those challenges. Kira macam hebat lah. You can say anything. You kata biasa-biasa je. Taklah nak kata hebat sangat. Padahal tak nak tunjuk riak kan. Tapi nak ceritanya, I acknowledge that you memang power lah. Bukan sebab saya pun pernah dulu macam you juga kan. Tapi nak katanya you guys memang power. Tapi your potential tu, where are you going to check it? And in this hadith, Nabi SAW said, it's either you can channel it to ignorance or you can channel it to Islam. Sama macam tadi, kalau kita letak potential difference tu, kita punya battery tu, in the correct orientation, positive and negative, then you will have the current flowing in the correct direction and everything would light up. But if it is the other way around, you are being ignorant. You are being ignorant on the signs of positive and negative. You won't be able to nak jalankan jam kan, that clock kan. If you put the battery in the wrong direction, the clock won't even move. Even a simple wall pun takkan berjalan. Not to say aeroplane ataupun a big vehicle, rocket contohnya, if everything is it is in the wrong direction, without any direction, if you are ignorant of the direction, that potential would eventually go to waste. Dia akan deplete, habis macam tu. Macam contoh, I'm not sure kalau you guys yang duduk kat rumah kan sepanjang 40 hari kan, your parents yang work from home, ada tak kalangan your parents yang ada masalah bila hari ni nak pergi kerja, bateri kereta kong, bateri kereta tak jalan? Ada tak yang terpaksa jump start? Ataupun if you notice sometimes kalau throughout the 40 days period yang kita duduk ada kadang-kadang parents akan turun bawah, akan start engine sekejap kan. Sebab if that potential in the battery is not being used properly in your car, then eventually it will die. Then you will run out of battery. Sebab adalah orang kena pergi jump start. Orang akan panggil battery.com kan. Tapi nak ceritanya, each and every one of you have got potential. It's a matter of you channeling it to the proper direction, the proper avenues. And the Prophet he said that the only way for you to be able to channel your potential to Islam, to the submission of Allah subhanahu wa ta'ala, is when you understand. So that is where the difference comes in. It's not that you know. It's not a matter of knowing knowledge, but to be able to understand and to withstand the wisdom behind the knowledge. That is what is important. Okay? So, ceritanya, we've got our potential, we've got our conductivity, our metal. Now it's a matter of understanding. Problem is, the Nabi SAW left us hanging here. He did not say, What do we have to understand? Knowledge is vast. Is it to understand everything? But it's not. There is one particular thing that you need to understand. And when you understand that thing, inshallah, you'll be able to differentiate where you want to channel your talent and your potential, either to Islam or Jahiliyyah. And if you understand this thing, you'll be channeling it to the proper channel, inshallah. Wallahu a'lam bishawab. So that's it for me, inshallah. Hopefully you guys benefited from our session. Thank you very much for those who attended my session last Saturday. InsyaAllah kalau ada rezeki nanti kita jumpa lagi lah bila-bila. Okay. So I think that's it. I see you guys probably on Thursday. Tapi Thursday dah cuti kan. So I'll send the itinerary because tomorrow we'll be starting a new chapter, chapter 12, which is one of my favorite topics. Bukanlah favorite, benda yang saya terpaksa ajar like 3 years in a row. Playing around with the circuits. Tapi kita tengoklah esok macam mana. So hari ni dah tak ada apa-apa, boleh relax, enjoy your Ramadan. Make sure you increase your ibadat, your Quran, your reading of the Quran, and don't forget your Qiyamul Lail, don't forget your sahur, because there is barakah in the sahur, insyaAllah. Send my regards to your parents, insyaAllah. So I'll see you when I see you, insyaAllah. Kita boleh tangguh. Kita press red function tak? Sekarang.
Function.
MasyaAllah. Okay.
Thank you, sir.
Thank you, sir.
Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. والعصر إن الإنسان لفي خسر إن الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر آمين.
Amin.
And if anyone has got a video connected, you can switch it on. Let me just take a photo. Yes, insyaAllah. Cepat. I'll count to 3. Tapi ada video boleh on. So kita ambil gambar. Okay, ready? 1, 2, 3. Okay, 3 orang saja yang support saya. Terima kasih banyak orang-orang yang telah support saya, insyaAllah. Okay, I'll see you guys. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.